Welcome back. The topic of this interactive video lesson is on reflections and symmetric figures. Let's start by defining reflections. A reflection is a geometric transformation that flips a point, a line, or a figure across a line that is called the axis of reflection. The reflection of triangle ABC looks like this. Triangle A', B', C'. Triangle ABC is the original figure. Line S is the axis of reflection. And triangle A', B', C' is the reflected figure. Line S is the perpendicular bisector of line A', line B', and line C'. In other words, A is the same distance from S as A' is from S. B is the same distance from S as B' is from S. And C is the same distance from S as C' is from S. Drawing a reflection with a compass and ruler. We can draw the reflection of line AB over S using a compass and ruler. First, draw a line through point A perpendicular to S using a compass and ruler. Construct the perpendicular bisector of S through A. To do that, draw an arc from A through 2 points on S. Then, from those points on S, draw another arc. Where those two arcs intersect, we'll draw a line from A to that point. Note that the distance from A to S is the same as A' to S. Now draw a line through point B perpendicular to S using a compass and ruler. Again, we'll draw an arc from B that intersects S in 2 places. And from each one of those points, we'll draw an arc. And where those 2 arcs intersect, that's going to be B'. We'll draw a line from B to B'. And note that the distance from B to S is the same as B' to S. Now we draw a line from A' to B'. Now we can erase the markings, and here we have the reflection of AB over line S. Drawing a reflection with a set square and ruler. We can also draw the reflection of line AB over S using a set square and ruler. First, draw a line through point A perpendicular to S using a set square. Like so. Now measure the distance from A to S, then find A'. It's the same distance on the other side of S. Here's A'. Now we can draw a line through point B perpendicular to S using a set square. Extending the other way. Now measure the distance from B to S, and then go the same distance on the other side of S. And that's where we'll place B'. Now we connect A' and B'. And that's how we can draw a reflection with a set square and a ruler. Finding the axis of reflection with a compass. If we're given an original figure and its reflection, we can find the axis of reflection between them with a compass. First, draw a line connecting point A and point A'. Now construct the right bisector of A' using a compass and ruler. To do that, we use our compass, drawing an arc from point A, going through the line, and then not changing our compass, we draw an arc from A'. And where those 2 arcs intersect, we can draw a line through those points. And now this is line S, the axis of reflection. We can also construct the axis of reflection with just a ruler. First, draw a line connecting point A and point A prime. Now draw a line connecting point B and point B prime. Now find the midpoints of line A, A prime, and B, B prime. We can measure and mark the midpoint on both of the lines. Now draw the axis of reflection through the midpoints. And that's line S, the axis of reflection. Symmetric figures. A figure is said to be symmetrical if an axis of reflection can be drawn through it. For example, consider this isosceles triangle. We know that angle A is congruent to angle C. We also know that line AB is congruent to line AC. An axis of reflection can be drawn through vertex B of this isosceles triangle. Line S can be called the axis of symmetry because vertex A is the image of vertex C and vice versa. All isosceles triangles are symmetric figures. Some symmetric figures have more than one axis of symmetry. For example, a square has 4 different axes of symmetry. Here's one, here's another, a third, a fourth. Lines S1, S2, S3, and S4 all make an axis of symmetry in the square ABCD. This means that all squares are symmetric figures. Let's look at other triangles and quadrilaterals and determine if they are symmetrical. Triangle ABC is an equilateral triangle. Angle A is congruent to angle B, which is congruent to angle C. Line AB is congruent to line BC, which is congruent to line AC. Equilateral triangles have 3 axes of symmetry. Here's the first, here's the second, and here would be the third. Notice all of the axes of symmetries are perpendicular to the sides. All equilateral triangles have symmetry. Triangle ABC is a scalene triangle. That means none of the angles and none of the side lengths are congruent. Scalene triangles have no axes of symmetry. Scalene triangles are not symmetrical because they have no axis of symmetry. ABCD is a rectangle. That means that each of the vertices are 90 degrees. That also means that line AB is parallel to line CD and line BC is parallel to line AD. Opposite sides are parallel. Rectangles have 2 axes of symmetry. Here's one, and here's the other. These are both perpendicular to each other. All rectangles have symmetry. ABCD is a rhombus. That means that the opposite sides are parallel, it's a parallelogram, and that also means that all of the side lengths are congruent. We also know that angle A is congruent to angle C, and angle B is congruent to angle D. Opposite angles are congruent in a rhombus. Rhombi have 2 axes of symmetry. Here's the first, and here's the second. And these are perpendicular to one another as well. All rhombi have symmetry. ABCD is an isosceles trapezoid. That means the bases are parallel, AD is parallel to BC, and the 2 non-parallel sides are congruent, so AB is congruent to CD. This also means that angle B is congruent to angle C, and angle A is congruent to angle D. Base angles are congruent in isosceles trapezoids. Isosceles trapezoids have one axis of symmetry, right here. So all isosceles trapezoids have symmetry. ABCD is a right trapezoid. BC is parallel to AD, and angle A is congruent to angle B, which is 90 degrees. Right trapezoids have no axes of symmetry. Right trapezoids are not symmetrical because they have no axes of symmetry. ABCD is a parallelogram. That means that the opposite sides are parallel. We also know that opposite sides are congruent. Parallelograms have no axes of symmetry. Parallelograms are not symmetrical because they have no axes of symmetry. Alright, now we're ready to do further examples.